Here we see the fourth part of the ninth lab, the diode lab, and in this particular circuit we have this 10 kilo ohm linear potentiometer, which is in parallel with a 10K fixed resistor. And this allows us to actually adjust the input signal before the diodes play their part in clipping and distorting the original signal. So this allows for an adjustment basically of the input. And this will actually somewhat affect the way that the diodes clip the signal, because the harder, so to speak, that they are fed voltage of the original signal, the sharper the clipping wave will be. So here we can see a combination of the original sine wave circuit, which is right here, and we have the resultant wave here, which is this pretty much the same as the previous part of the lab. And that's all well and good, but now that we have this potentiometer, we can adjust the resultant wave. So I can actually lower the input wave gradually. Now, interestingly, even though this is a linear taper potentiometer, which is the type B, it very quickly drops off. So only a very small portion of the turning arc of the potentiometer really affects much of the voltage, which is rather annoying. I'm not exactly sure why this is the case, but what's important to note here anyway is that as I change the input voltage ever so slightly, you can see that the resulting clipping wave from the diodes changes ever so slightly. When the input voltage is higher, the sides of the banks of this clipped wave are steeper, and when it goes down, they become a little softer. And by the time that it gets so low that my oscilloscope simply cannot hold its trigger, the input voltage and output voltage are not identical, but closer, because the diodes are not clipping the output signal as hard. And so this is the fourth part of the diode lab, and thank you for watching, and I hope you learned something. See you later.